Welcome back for another deep dive. Today we're taking a look at some cutting-edge research in the world of LLMs. You know, the kind that's really pushing the limits of what these models can do. We've got a whole bunch of academic papers, and they're all about, well, the latest breakthroughs, especially when it comes to things.
Oh, hey, welcome. What's up?
Hey there. Thanks for having me. Today we have plenty of papers, about 10, about the DeepSeek. So can we start from the DeepSeek-MoE? Go through this paper first.
Hey, glad to have you with us.
Yeah, absolutely. Happy to dive into DeepSeekMoE.
So, DeepSeek-MoE is all about training.
Strong models, but doing it economically.
Exactly. We'll get into the details.
Device-limited routing and token dropping strategy.
So, should we jump right in?
Let's do it.
Okay, cool. So, let's talk about efficient architectures.
Now, this next paper really grabbed my attention.
DeepSeek Prover, this model dives into the
World of automated theorem proving using Lean 4.
For those who don't know, that's a proof assistant.
This is where things get interesting. Theorem proving,
It's a tough nut to crack. It needs
rigorous logical thinking, and, oh yeah, go on.
First, we can go through the DeepSeek-MoE.
Absolutely, we can start with DeepSeekMoE.
All right, so DeepSeek-MoE focuses on training strong models.
And, doing it without breaking the bank.
Exactly. It's about efficiency, which is so important.
So for those just tuning in, Mo means?
Mixture of experts. It is an approach to language models.
With Mo, you divide the model into these modules.
Right, and each of these experts specializes in something.
Instead of one model doing everything, you have specialists.
Yeah, it really helps with efficiency and performance.
Okay, so how exactly does DeepSeekMoE achieve this?
Well, a big part of it is what they
Call fine-grained expert segmentation.
This means breaking down the experts into smaller pieces.
It allows for higher specialization and knowledge acquisition.
Another key idea is isolating some shared experts.
This helps to mitigate knowledge redundancy among experts.
It prevents the experts from learning the same things.
Okay, so what makes this better than G-Shard?
Good question. With the same parameters, it outperforms G-Shard.
Impressive. The architecture allows for higher expert specialization.
We touched on DeepSeek Prover, but let's put a pin on
that for now. We'll come back to it later.
What's fascinating here is how they scale this Mo.
The DeepSeekMoE architecture was validated starting at 2B parameters.
The scaling shows it can nearly approach performance.
How is DeepSeek able to achieve this performance?
With fine-grained expert segmentation and shared expert isolation.
We could dig deeper into that later.
Let's move on to DeepSeek-V2.
Okay, DeepSeek-V2 also uses this efficient architecture?
Correct. It uses multi-head latent attention.
It also uses the DeepSeekMoE architecture.
One of the things I like about DeepSeek-V2
is how they made it efficient for deployment.
They converted the parameters into the precision of FP8.
They also performed KV cache quantization.
Ultimately, it requires less KV cache than DeepSeek 67B.
What kind of throughput are we talking about?
Exceeding 50K tokens per second on a single node.
Okay, should we come back to the other papers now?
We can do that. I'm glad you're here with us.
Yeah, always great to have your questions.
Okay, cool. Let's move on to the next topic.
Let's quickly revisit automated theorem proving with DeepSeek Prover.
As a reminder, DeepSeek Prover dives into Lean 4.
DeepSeek, go for it.
Absolutely. We can keep going with DeepSeek-V2.
Yeah, we're happy to keep digging in there.
So one thing that's fascinating is DeepSeek-V2 Lite.
DeepSeek-V2 Lite is one of the smaller models, right?
It has 27 layers and a hidden dimension of 2048.
That's still pretty powerful considering its size.
It also uses multi-head latent attention, or MLA.
What about the mixture of experts architecture?
It also uses the DeepSeek-MoE architecture, yes.
So how many parameters are activated?
2.4 billion parameters are activated for each token.
That's efficient, given its capabilities.
So it supports 128K context length.
I'm curious, how did they make it so long?
They applied YARN for context extension.
They progressively expanded the context window from 4K
all the way to 32K and then to 128K tokens.
That is how they got such a long context.
Another interesting aspect is multi-token prediction.
Instead of one token, it predicts the next two.
Yeah, it significantly accelerates the decoding speed.
That's how they get 1.8 times tokens per second.
They improve the decoding speed of the model.
That's a clever way to speed things up.
For training, they use the AtomW optimizer.
They adjust the learning rate according to specs.
So they're not just pushing text processing.
They're also looking at code generation with DeepSeek Coder.
We can dig deeper into that later.
What about some of the limitations of DeepSeek?
It is primarily designed to support text modality.
They are planning to enable support for multiple modalities.
That would enhance its versatility in wider scenarios.
In the future, they'll invest.
Oh yeah, let's hear it.
We know the DeepSeek-2 adopted the MLA and multi-token prediction. What about the DeepSeek V3, the next generation of the V2?
Okay,
It's great you're thinking about the bigger picture.
so as far as DeepSeek V2 adopting MLA goes,
Yeah, it definitely uses MLA, which is cool.
right, it utilizes that low-rank key-value joint compression.
That eliminates the bottleneck of inference time key-value cache.
As for multi-token prediction, it also uses that.
I think it's used to improve the decoding speed.
And, it's got a high acceptance rate.
Okay, and then you're asking about DeepSeek V3.
Yes. DeepSeek V3 also uses the MLA architecture.
It also uses DeepSeek-Moe, from what I understand,
Okay, is there anything else you wanted to discuss?
such as general capability and language mixing.
We can talk about self-rewarding and distillation.
DeepSeek is trying to make the model better.
It is also trying to make it faster.
Okay, so that about wraps things. Oh, yeah. Uh-huh.
Yes, definitely. I want to talk about the V3. So what's the improvements, the key points or intuition for this V3?
Gotcha. You want to know about DeepSeek V3's improvements?
Yeah, let's dive into the key improvements of V3.
Okay, so DeepSeek V3, it's a big mixture of experts model,
It has 671 billion total parameters.
but only 37 billion are activated at a given time.
It was trained on almost 15 trillion tokens.
One of the big improvement is this auxiliary loss-free strategy.
It helps with load balancing.
So you want to minimize adverse impact to model performance.
Right, you want to encourage the load to balance.
Another key point is the multi-token prediction.
It enhances overall performance.
What else stands out to you about DeepSeek V3?
Well, it's really strong on knowledge benchmarks,
Yeah, like MMLU, it gets some state-of-the-art results.
especially compared to other open source models.
And it's really good at Chinese factual knowledge, too.
It's also a beast on math and coding tasks
They even use it as a generative reward model.
to provide self-feedback and improve.
Yeah, that self-rewarding approach is really innovative.
They're using the model to improve itself.
It's really efficient, too.
It supports FP8 training.
Anything else to talk about with DeepSeek V3?
Well, let's see. They also distilled the reasoning capability.
Distilling it from the DeepSeek R1 models.
Overall, it's a really impressive model.
Thanks for joining us, Dive.
We hope you found it as interesting as we did.
And thanks for all of your questions.
Yep, go on.
I thank you for you bring up the reasoning ability. So the GRPO referred from the V3. Do we have a more detailed explanation?
Absolutely. I'm glad you brought that up.
Okay, let's unpack this a bit.
So you're asking about the reasoning abilities.
How DeepSeek hones that skill, right?
The base model can use chain of thought prompting.
That's where it breaks down problems step by step.
DeepSeek models use code in the pre-training process.
Right, it trains alongside text data to boost reasoning.
It strengthens reasoning by increasing training data diversity.
Prompting is like a technical method.
Yeah, it helps the model show off its reasoning ability.
It uses chain of thought for arithmetic tasks.
There's also a few-shot chain of thought.
This is where you give the LLM reasoning examples.
These detailed examples are chain of thought prompting.
That's how the model learns to reason.
It improved the accuracy of GSM-8K.
Okay, I think that covers it for now.
Did that explanation help clarify things for you?
We're always happy to dig into the details.
Okay, should we move on then?
Absolutely. Now, where were we?
Thanks for your questions.
It helps us to know what you're interested in.
We always appreciate your insights.
And it was, back to our listener. What's up?
Yes, the GRPO, can we explain the detail of it? Can we explain more?
Sure, we can elaborate on that.
So when you're talking about GRPO,
You're referring to generative reward policy optimization.
that's a way to fine-tune the models.
Exactly. It helps align the LLM with human preferences.
It also uses self-feedback to improve.
So first they trained DeepSeek on a massive data set.
That dataset included both text and...
Yeah.
Sorry to interrupt. Group relative policy optimization.
Gotcha. You want us to keep going?
Yeah, let's get into the nitty-gritty of GPO.
Okay, so after training on text and code data,
Then they used GRPO to distill knowledge.
distilling from the larger DeepSeek R1 models.
And the DeepSeek models then provide self-feedback.
It is the self-rewarding approach we mentioned.
Exactly. To go further into GPO algorithm.
GPO samples a group of candidate outputs.
From the old policy for each question prompt.
It optimizes the model based on relative rewards.
The prompt selection is designed strategically.
It includes both correct and incorrect proofs.
This enhances the training process significantly.
And it aligns well with GPO's group relative nature.
Another cool thing, GRPO forgoes the critic model.
In other words, no need to train another model.
This reduces the training costs of reinforcement learning.
It's a clever way to save on resources.
Now, as for the self-feedback,
The whole process refines the model overall.
it makes it more aligned and, hey, yeah, what's up?
So what's the difference between the PPO and the GRPO?
Okay, let's dig into that a bit.
You want to know PPO versus GPO, right?
Well, PPO uses a value function.
Yeah, it needs to train another model,
That other model has comparable size.
whereas GPO forgoes the value model.
It estimates the baseline from group scores,
Right. So it really cuts down on resources.
the training resources, I mean.
Memory, computation, all that.
It's a more streamlined approach.
GPO aligns well with reward models.
The reward models compare outputs on the same prompt.
Also, GPO skips the KL penalty in the reward.
It skips that and directly regularizes the loss.
We covered self-feedback earlier, too.
Yeah, so both are useful in different ways.
Did that give you a bit more insight?
Oh, go for it. I think I understand. So you're asking.
Are we really on track with our chat about DeepSeek?
You want to make sure we're explaining things well?
Yeah, let's step back and make sure we're clear.
So we started with DeepSeek-Moe architecture.
That's right, it was to train models efficiently.
This model is also fine-tuned for chat.
The fine-tuning helps to do helpful responses.
DeepSeek-V2 uses multi-head latent attention.
And it uses the DeepSeek-Moe architecture.
Ultimately, it requires less KV cache.
Then we talked about V3's improvements.
It uses auxiliary loss-free strategy.
Also, multi-token prediction is used.
And what about GPO's group relative nature?
It skips the KL penalty and directly regularizes.
You also asked about self-feedback earlier.
Do we miss any key points, do you think?
Were there any topics that we should explore?
Or should we move on to DeepSeek Prover?
Or we can wrap things up for today.
Yeah, it was great digging into this with you.
Always great to have your questions.
It helps us.
Oh, yeah,
Okay, we go through from the V2 and V3. Now we have the DeepSeek Coder V2. Can we wrap up the key intuition of this work?
Got it. You're saying we should recap DeepSeek V2 and V3?
Before we wrap things up for today.
Well, let's just hit some of the... Oh, yeah,
I mean, we can go into the DeepSeek Coder V2.
Ah, I see. You're suggesting we shift our focus.
You want to talk about DeepSeek Coder V2?
Instead of wrapping up with V2 and V3.
Okay, we can definitely do that.
Let's switch gears and talk about code.
All right, DeepSeek Coder V2 it is.
So what makes DeepSeek Coder V2 special?
Well, for starters, it's an open source model.
And it is comparable to GPT-4 Turbo in coding tasks.
That's a pretty big deal for open source.
Yes, it's a huge advancement for the community.
So it was pre-trained from DeepSeek V2.
It had an additional 6 trillion tokens.
Wow, that's a lot of code.
It enhanced coding and math reasoning.
And it extended its language support.
It supports 338 programming languages now.
It also extended the context length from 16K to 128K.
It allows it to handle extensive coding tasks.
So how does it achieve this performance?
It used the mixture of experts framework.
Only 2.4B and 21B parameters are activated.
It efficiently supports diverse applications.
So what else should we talk about?
They used AtomW Optimizer for training.
They also have DeepSeek Coder V2 Lite.
Consistent with DeepSeek.
Oh yeah, let's hear it.
Yes, we can talk about the fail in the middle. Differ from the next token.
Okay, let's unpack this.
Yeah, let's get into that middle ground.
It sounds like you're looking for a deeper dive.
Okay, so you mean the alignment phase.
Exactly. Let's talk about that a little more.
So in the alignment phase training,
They work to align the base model.
GPO was used for the reinforcement learning.
Aligns the model with human preferences.
Now shall we move on from that?
Now where should we go next?
What else should we cover?
Oh yeah, go on.
I mean, we are in the DeepSeek Coder. We adopt a new strategy, mask. I think, and fail in the middle. Can we talk about that?
Gotcha. You want to talk about fill in the middle?
Yeah, you want to know how that works in DeepSeek Coder?
We could definitely dig into that a bit more.
So DeepSeek Coder Kara V2 uses fill in the middle.
And it is during the fine-tuning of the base model.
This approach helps it predict text accurately.
So it can fill in the gaps in the code.
With the 16 billion parameter model.
Right. It's like giving the model a puzzle to solve.
And this improves its coding abilities.
Okay, is there anything else you wanted to discuss?
I guess what makes this EFIM different?
Should we talk about the prefix-suffix middle framework?
Or shall we move on from that?
Now, where should we go next?
What else should we cover about DeepSeek Coder V2?
Should we wrap things up for today?
I think we've hit the key highlights.
It definitely enhanced the coding and math reasoning.
It now supports 338 programming languages.
To the mixture of experts architecture.
From pre-training to fine-tuning.
The body has lots of strengths.
Do you think that answers all of your questions?
Or were there any topics that we should explore?
We can dig into any topic you want.
Should we wrap things up for today then?
Well, it was great having you with us.
Different how?
Are you saying that there's something off?
Like, should we be talking about something else?
Or maybe you're looking for a contrast.
A different approach to GBRO altogether.
Let's clarify so we can help you out.
It was a pleasure digging into DeepSeek today.
It was a pleasure digging into this stuff.
It helps us to know what you're interested in.
We always appreciate your insights and your questions.
So I guess that's about it, right?
Thanks for being here.
What do you mean by very far?
How does it relate to GPO?
We could definitely make this clear.
Once we know what you're looking for.
Okay, that wraps up our discussion for today.
It's been a fun conversation.
Oh, go for it.
Hey, yes. Just we go through the coder. So can we go to the coder V2, the version 2 for the coder?
Got it. You want to keep going with DeepSeek Coder V2?
Yeah, instead of fill the middle, we can switch focus.
So let's see. Where should we?
We could talk about the base and instruction models.
The DeepSeek Coder series comprises open source models.
Their sizes vary from 1.3B to 33B.
Each model is trained from scratch with 2 trillion tokens.
Right, and these tokens are sourced from 87 languages.
But V2 has 338 programming languages.
True, but this 87 language finding is still pretty cool.
They organized pre-training data at the repository level.
That enhanced its understanding of cross files.
You know, it helps the model see the bigger picture.
The models also use fill and middle approach.
It further bolstered the model's code completion capabilities.
Also, they extended the context length to 16K.
V2 has a context length up to 107.8K.
How do they make the models better?
We can dig into the training.
What do you want to focus on?
You mentioned very far in the middle.
Could you tell us a little bit more?
What do you mean by very far?
What is your intuition here?
We can definitely make this clearer for you.
Once we know what you're looking for.
Okay, that wraps up our discussion for today. Oh yeah, let's hear it.
It seems that the DeepSeek coder just the data side the work. So from the coder the programming ability to the math prover, can we talk about the DeepSeek prover? How do they use another symbolic language to do this job?
Ah, I see what you're getting at.
Yeah, you want to talk about DeepSeek Prover
Curious how it uses symbolic languages.
instead of programming languages or math problems.
Well, DeepSeek Prover tackles formal theorem proving.
It uses the Lean-4 proof assistant language.
So this is really rigorous logical thinking,
You need a deep grasp of mathematical concepts.
instead of brute forcing it with high-level tactics.
The model integrates natural language reasoning.
This is where the chain of thought comes in.
It helps guide the generation of tactics.
So it first inserts natural language solutions.
At the beginning of the proof block as comments.
That's how the model guides the tactics.
It also develops behaviors with this approach.
So you want a delicate math thinking behavior.
LeanStar performs chain of thought reasoning. The framework establishes an AlphaZero-like pipeline.
Is there anything else you wanted to discuss?
We can dig into any topic you want.
Or should we wrap things up for today?
Well, it was great having you with us.
This is a fun discussion. We reached the end of our show.
Thanks again for joining us.
You're curious.
Oh, yeah. Uh-huh.
You're asking about DeepSeek Prover V1.5?
You want to know how they improved it, right?
Okay, so with V1.5, they optimized the training.
Right, and the inference processes too.
They also use something called RLPAF.
Reinforcement learning from proof assistant feedback.
This refines the model even further.
And they introduced RMax-TS.
It's a type of Monte Carlo tree search,
It helps to explore different proof paths.
so it can achieve new state-of-the-art results.
The tree search elevated pass rates a bunch.
It made theorem proving way more effective.
Did that explanation help clarify things for you?
Or is there something else about 1.5 you want to know?
We can dig into any topic you want.
Or should we wrap things up for today?
What?
Yep, go on.
Just slow down. We can explore the prover 1.5 with the MCTS. So can we give the detailed explanation of the FCTS?
Got it. You want more on MCTS and DeepSeek Prover 1.5.
And you're curious about RLPAF, is that right?
Okay, so MCTS is used for exploring proof strategies.
It helps the model figure out the best moves to make
It's really good for finding solutions.
because theorem proving has so many possibilities.
As for RLPAF,
That stands for reinforcement learning from assistant feedback,
DeepSeek Prover learn from interactions.
just like a student learning from a teacher,
RLPAF uses a reward signal,
then fine-tunes the language model.
so it generates successful proofs.
It is all through reinforcement learning.
We can discuss RMax-TS, also from 1.5.
RL is also used for language model alignment,
This helps the model generate solutions.
also the exploration aspect of reinforcement learning.
But the problem of proof search remains.
You have to train a critic model.
Assess incomplete proofs and prune branches.
So RMax-TS promotes exploration of proof steps.
Did that explanation help clarify things for you?
We definitely go into more detail.
Or we can wrap things up for today.
We'll catch you next
Have
time.
a great rest of your day.
It is. Oh, back to our listener. What's up?
Yes, it's good. So we just do the math. Explain the math of the and we know the DeepSeekMath. This paper gave a unified paradigm.
I'm glad you brought that up.
Ah, yeah, uh-huh.
So you know what I mean. The unified paradigm for the whole post-training process. Can we dig into this one?
I think I know what you mean.
The unified paradigm for post-training. Gotcha.
This is where things get really interesting.
So this paradigm analyzes different training methods,
Methods such as SFT, RFT, DPO, PPO, and GRPO.
and it gives a gradient equation too,
The gradient is with respect to the parameter
to see how different methods work.
and where they might have common ground.
It's a cool way to compare them.
Yeah, all of these methods have a common form.
The methods are direct or simplified RL techniques.
It helps to understand them all in one go.
So you can dig into each of those pieces.
We can also talk more about DeepSeekMath.
How does it do well on math benchmarks?
What do you want to talk about more?
We can dig into any topic you want.
Or we can wrap things up for today.
I think this listener's having a great time.
It is great. Hey, yeah, what's up? I think we can definitely get into that.
Yeah, let's break down this for you.
So the data source determines the training data.
That's the raw stuff the model learns from.
In RL, it's unlabeled questions and model outputs.
And then there's the reward function.
That's where the training signal comes from.
It guides the model towards better answers.
The reward comes from DeepSeekMath itself.
Also from human preference data and code feedback.
Lastly, we have the algorithm A, which does stuff.
Like it processes the data and reward signal.
It determines the magnitude of the reinforcement.
It decides how much to punish bad data.
We can talk about this more in terms of math.
But where should we go next?
We can move on to DeepSeekMath if you want.
And we can wrap things up for today.
What do you think about this so far?
It is great to talk to the community.
We appreciate. Oh, go for it.
Yes. So can we wrap up with the process or the
You want to know how to wrap?
Oh, yeah, uh-huh.
Yes, the journey of the DeepSeek RE, how to success to train this reasoning model. We can give a conclusion and we can give a further.
You want to know how to run the training process?
We want to make sure we got all the key steps, right?
Yeah, so let's quickly recap how to train it.
We talked about the data source already, right?
That's the raw material the model learns from.
The reward is also super important.
That's the signal that guides the model.
We talked about the algorithm, too.
I think we mentioned gradient and CSIN is used.
This equation is with respect to the parameters.
And how do you train the DeepSeek-Math model?
There is a lot of supervised fine-tuning going on.
Did we mention DeepSeekMath is multilingual?
Also, the way DeepSeek selects good data.
Yeah, that helps them get high-quality data.
And also the reinforcement learning that they used.
To boost the benchmark performance scores.
Is there anything else we can help you with?
If not, I think we can wrap things up.
Or let's talk about math a bit more.
Okay, so let's dig into the DeepSeek-Math paradigm.
They touched on DeepSeek Prover earlier, right?
Yeah, we can talk about math specifically now.
So DeepSeek-Math really pushes the limits.
It pushes the limits of mathematical reasoning,
It's all thanks to their data selection pipeline.
helps them select really good training data.
Yeah, that data comes from Common Crawl.
They made a big corpus of 120B math tokens.
7 times the size of used.
And DeepSeek-Math does well on benchmarks.
Right, covering problems of all sorts.
Oh, and DeepSeek-Math is multilingual too.
It helps with the Chinese benchmarks also.
They also compared against Minerva and others.
It helps to see where the strengths lie.
Did that explanation help clarify things for you?
Or is there something else you want to know?
We can dig into any topic you want.
Or should we wrap things up? Yeah,
Can we give the further research perspective?
I think I know what you mean.
So you want to know more?
You want to wrap up the conversation.
Before wrapping up the podcast.
You want us to dig into the DeepSeek Prover stuff.
Yeah, we touched...
Oh yeah, let's hear it.
I mean, conclude.
I understand.
Oh yeah, go on.
I mean, we just had read plenty of the papers and know the DeepSeek have a long process to achieve the high result, a high value, or the better result, the success of the RE. So, what's the research venues for this work for the future researcher?
Okay, let's try to summarize some research avenues.
Yeah, you want us to talk about future research, right?
One avenue is scaling laws,
Right, figuring out how to scale models efficiently.
like we saw with DeepSeek's work,
Another is the mixture of experts architecture.
how to make those models even more efficient.
Then there's automated theorem proving.
Improving those skills is something to consider.
You could use synthetic data.
DeepSeek Prover showed how to improve the model.
The paper talks about large-scale synthetic data.
The investigation reveals dataset size and model efficacy.
This shows the importance of data.
Yeah, we need data construction for automated theorem proving,
Also, reinforcement learning is really useful.
in that it improves instruction-tuned models.
There's also the question of math pre-training.
DeepSeek showed Common Crawl contains math data.
So there was a summary,
How to access the training process.
or do you want to know about a specific avenue?
We can also cover DeepSeek Prover.
Do you mean its theorem proving abilities?
I guess we can clarify.
Okay, so DeepSeek Prover uses Lean 4.
It's a proof assistant language, remember?
It does formal theorem proving.
You have to understand natural language reasoning.
It uses chain of thought.
That creates tactics with it.
We can also look at some examples.
They're in the form of comments.
I think that we should discuss this one.
One cool thing is Lean Star.
All of this is with V1.5 of Prover.
It pushed the limits of math reasoning.
Also, RL and huge token counts help.
I think we got through it all.
Did all of that make sense?
Well, it was great having you with us today.
It is always a pleasure having you here.
It is great to talk to the community.
You truly had some amazing curiosity.
Your presence is very fun for me.
Thanks again for joining us on our show.
Have a great rest of your day and keep learning.
You're such a fun listener to have around.
That's all the time we have for today.
We hope you learned a lot from our discussion.
And feel more informed about DeepSeek AI.
We appreciate you for joining us and helping us learn.
We'll see you next time. Goodbye.